So I'm Chris Tisdale. I'm a professor, and I've been at UNSW for quite a long time now. I've taught this course many times. I've lectured this course, and I've also tutored this course. So this term I'm doing the tutoring. So I know how this course works, and I know how things fit together. Okay, and I'm in Sydney at the moment. I'm coming to you from Sydney. All right, so let me have a look at these questions. There's 3 questions today, and I will share my screen. Chrome tab. All right, there's my big fat head. Hello. So let me go down to my document camera. All right, you should be able to see that. And let's have a look at the first question. So let me get a fatter pen. All right, here we go. So you want to solve the following inequality for x. Okay, so this is a very standard question that you probably see at high school. It's just got to do with a few different things where x is, you're trying to find x. Okay, Charlie's jumped in with x is less than or equal to 2. Okay, is that correct? There's lots of stuff coming in the chat. All right. Well, the first thing that I would be concerned about is, and Matthew's pointed it out, if we divide by 0 here, obviously that's not possible because you'll break it. So we would make the note here that x cannot equal 0. Now there's yeah, thanks, Zach, you're on that too. So a few things going on. We can solve this problem several different ways. So we can solve it using algebraic or graphical methods. So if you guys have a preference, which one would you choose, algebraic or graphical methods? They're both okay for this problem. Which one would you know, and which one do you think is better? Okay, people are loving that algebra. Some people are loving the graphical. Charlie says both. Okay. Well, let's have a look at the algebra way first, and then we can do some graphics if you want. It just depends what's working for you. Yeah, Ashna, sure, I use both. So you have to be careful with these inequalities, right? Because they're not like you have an equal sign. So when you multiply something here, if you multiply something that's both sides that's positive, then you can keep the same inequality sign. So one way of doing this is to multiply both sides by x squared. So yeah, so Cheng Tao, sorry. Yes, absolutely. We can. This is the first part of the algebraic method. As long as x is not equal to 0, you can simplify this, and then you can form a quadratic equation, right? Ooh, Arnav, Pradeep, why not just x? Why can't I just multiply this both sides by x? That is a great question. Let me go back to this one and say, that's a great question. Okay, why can't we multiply this just by x? Bring the x up there or something. Okay, because x might be negative, says Ricardo. Okay, yeah, you're right. When we multiply both sides by a positive number, then we can keep the same inequality. Okay, otherwise, as you say, you have to worry about whether it's positive or negative and stuff like that. So here, x squared is positive. Let's multiply both sides and we can simplify, right? So now, I'm going to bring that 2 up there. We have, so that's going to be x is greater than a half x squared. So bring the 2 up there. 2x is greater than x squared. Then what I'm going to do is basically bring the 2x to the other side. That's a side. Okay, so now we need to work out when is this thing less than or equal to 0. All right, so I'm going to plot the graph of this, which is pretty easy. Okay, so it's a quadratic function. It's going to cut the axis at 0 and positive 2, and it's going to look something like that. Okay, so if we look at this graph, then you can see, let me just go off there for a sec. Then you can see we want the part where this graph is sort of less than or equal to the horizontal axis. So that's the part there, and this is the corresponding x values. Okay, so from our graph, we know that x is going to be less than or equal to 2, and x is going to be greater than or equal to 0, but x can't be 0. So there we go. All right, so these are the range of x values that makes this true. Okay, so you can see here, you can see that I've actually used a little bit of algebra, and I did graph the function, which I just personally like doing. Okay. All right. So what's another way of doing it? We've talked about mostly algebraic ways. Well, what about a graphical way of doing it? Well, one way is to plot the graph 1 on x, plot the constant line 1/2, and then just look at the graph and see what happens. Okay, so that's 1 on x. That's a half, and here's your origin. Okay, and what you want is all the points where 1 on x lies above this horizontal line. So if I was looking at that, that's where the graph is above the horizontal line. This is 2 here, and so they're your points. Okay, so here's a graphical way of doing it. So it just depends what you prefer, right? Do you prefer this? You see this a lot in high school, right? You see this a lot in high school. You probably don't see this much in high school. Okay. All right, so a good question here is, do I have to write the answer like that? Are there any other ways to write the answer instead of this sort of inequality way? If you know a way, put it in the chat. Put it in the chat. What is another way? Yeah. Oh, here we go. Matthew, Stefan, Lucas, Jaden. Oh, okay. Definitely the brackets. I think we're on the right case with the brackets there, people. So another way, as people have put out, is 0, 2. The square brackets means we include 2, and the open brackets means that we don't include 0. Okay, some people ask me, oh, why the square bracket? Why the open bracket? Well, this includes the point at the end and this doesn't. Okay, so you could write X is in this interval. So this funny looking E is just is an element or a member of. Okay, so this is essentially saying the same thing as this. Okay, thanks for piping up. Zach, that's a good question. So Zach Rose in the chat has piped up and said very bravely, how does marking work for working? What if I have a different method to solving the question? Okay, so this is a really good question. Let me come back here. All right, so my fat head again. All right, Zach, it's a really good question. I think unless you're specifically asked to use a method, a particular method, then it's okay to use different methods. Okay, so unless you're specifically asked to say, use method A to solve problem B, and you use a different method, that's probably not a good thing. But if you're just asked to solve something, in my opinion, it doesn't matter. It doesn't matter. Okay. Arnav, sometimes it is, sometimes it is. Sometimes there, but my personal view is that you should be able to use any method you want, because you know why should we be just relying on one method? That doesn't make sense to me, because some people, let me go back to my big fat head. Some people, they're better at maybe algebraic methods. Other people, they're very visual, right? They're very visual learners. They like seeing pictures. Why should we like penalize those people? So I think for me, it's all okay. Okay, Sylvia Lim, why are the brackets different in the other form? So Sylvia, are you talking about this one here? There's one sort of round bracket and one square bracket. That's a really good question. So the round bracket means you do not include 0. And the square bracket means you do include 2. See how we've got a greater than and a less than or equal to? You have curved or square brackets. Okay, so Sylvia, did you get that? So if you have a strict inequality with no equals, it's a round bracket. If you have a square one, it's sort of less than or equal to, or greater than or equal to, whatever it is. Okay, welcome. All right, Zia, am I correct in assuming we are not allowed graphic calculators? Well, in the final exam will be done on Maple TA, right? So you will be able to use Maple in the final exam, and probably in lab test 2 as well. So you will be able to use technology to help you out. Does that help, Zia? Let me know if that helps. All right, so don't stress, okay? Don't stress. Yeah, don't freak out. All right, so let's move on to the next question. What does the E mean? Oh yeah, is an element of. Sylvia, so basically this is just a funny symbol that says X is a member of this set, okay? Is an element of. Can you see that down there? Okay, great. Okay, let's have a look at another example. We'll finish that off. And I can share something else. Okay, so let me share again. So much sharing. Okay, you should be able to see this question. We've solved question 1. Now the question involves solving cosine x equals sine x. Okay? So there's a few different ways we can do this. So one of the easiest ways is to simplify this to solving like tan equals 10. So we get 10. Yeah. Peter, I think you're on. Yeah. And Stefan. Yep. I think you're right. Sounds like a good plan. All right. So let's try that. So let's go back and we can, yeah, Ricardo, graphical. I actually lean to the graphical way myself, but let's have a look. Okay, so I will just share my, all right, so the suggestion in the chat is to solve this for x. Now, before we actually solve it, I think we have a method here, but what does this mean? Huh? I'm confused. Can anybody smash that chat button and tell me what actually that means? All right, x is real. X is a real number. Oh, Sharon, thank you. Yeah. So a few people have asked this question in the chat already. Yeah, we want to find all those real numbers. So it's for really for all, or for, I guess, we want to make sure that we catch all the numbers. These things are a bit like Pokemons, right? We want to catch them all. Okay, so Marley's come up with a suggestion, 45 degrees. Usually in calculus, we use radians, but you're right. So Marley and Zia, is that all the solutions though? Because you're right, if we put in pi on 4 there and pi on 4 there, we get 1 on root 2 on both sides, right? So it is you're right, but you haven't caught all the solutions. So you want to catch them all like Pokemon, right? So that's all right, Marley, no worries. It's a starting point, you know, like it's good to think about it. So let's do what a few people have suggested. And let's turn it into tan, right? So that'll be sine x on cosine x. And one way to solve it is just look at this problem. And someone in the chat before mentioned a graphical way of doing it. So let's have a look at that, because I do have some. Let me share my screen again over here. All right, so if you don't know about this, this is one of the most amazing programs ever. It's called GeoGebra. Okay, and let me put the link in, because it is such a good free program that you should try to get it if you can. I would highly recommend it. Okay, and yeah, Desmos is good too. Desmos is good. Nothing against Desmos. Desmos is no disrespect. Okay, so here's tan x. Okay, and you can see that it is a periodic function, right? It repeats, so it copies and repeats, and it's not defined at pi on 2 and negative pi on 2 and multiples of that. So if I put in 1, you can see here that there are an infinite number of places where the two graphs intersect. And you're right. We can start with pi on 4. Pi on 4 will be there. And it'll be pi units apart in both directions. Okay? So from a graph. So let me stop sharing. Okay. And share my Chrome tab. Okay. So we know that x is pi on 4, but that doesn't catch them all, right? You can get all the other ones just by adding or subtracting a multiple of pi. So remember here, we're talking about radians, and pi radians are 180 degrees. So if you're a bit rusty, just remember pi radians is 180 degrees. Now, some of you may be looking at that and going, well, Chris, like, I just want to do it just by hand. Well, that's fine. If you don't like graphing things, no problem, okay? But how might we do it by hand? So Sylvia, what is the real number? Well, there's lots of real numbers. So pi on 4 plus pi, pi on 4 minus pi, pi on 4 plus 2 pi. So there's an infinite number of solutions, Sylvia. Oh, what is a real number? Oh, okay. Oh my goodness. Now we're getting into it. All right. So this is a huge question, Sylvia. All right. So you've got integers, right? So they're whole numbers. You've got rational numbers. Oops, can't spell. So that's when you have one integer divided by another integer. And then you have irrational numbers like pi, root 2, e, etc. And together, these two things make up the real numbers. Okay, so probably the easiest way is just draw a number line, right? On that number line is the whole set of real numbers. Okay? All right. Good, Sylvia. Okay, so what's another way we can do this question, a different way we can do this by hand? Anybody know? Because it's easy to graph, right? Anyone? Ah, yeah, Ricardo, not bad. We can do that. Unit circle, yeah, we can do that. No problem. I know you're not shouting, Ricardo. Another way, and this is just one thing that I've been messing around with this morning. So unit circle will work. Another way is to just write this a bit differently and combine that into one sine function. And then look for the zeros of this. Okay, so how do you go from here to here? Well, this is actually part of the revision problems. Okay, so if you want to solve this problem, then it's that, and so you want to find the zeros of this function here. Okay, so that's not too hard to work out, but let me show you. Let me show you another graph. Okay, apologies to the Desmos crew. We're back on GeoGebra. There's sine x minus cos x. And you can see there's an infinite number of places where it cuts the horizontal axis. And if I put in square root of 2 times sine x minus pi 4 is, and you can see, oh my goodness, it's the same function. Wow, okay, so that's another way of doing it. Unit circle has been suggested in the chat, which is also good. So let me go back there. Okay, so another way of doing it, I won't do the whole details, but so this is like the first way of doing it, this is the second way of doing it, and then a third way, if I can just squish it into the bottom part. So this, basically, the tan says, if the tan's 1, then you've got basically a line with slope 1, okay? And so this is like the angle here, and you want to find out where it touches this unit circle. So, you know, you can have that angle there, and you just keep on going around and around and around. So you'll get the same answer as over here. All right? Whew, okay. Let me go back to the chat. Okay. All right. One more question, and then I think at the end I'll take some other questions. So the last question is question number 3 on the list. It's another inequality question. All right. It is this one here. So let me just find it. Yep. X plus 1. Okay. So there are a bunch of ways of doing these problems. Can anyone suggest how we might start? How might we start this problem? RV is saying that x is greater than 0. So you're saying, are you saying that this thing here is non-negative or something like that? Yeah. Let's put that down, Lucas. Thank you. Let's keep an eye on that. Okay. Yeah, Ariane, I think you're on the right track there. We know that this left-hand side it's non-negative, right? So we can, in this case, we can actually square both sides, right? So we can do a couple of things here. Basically, we can do this. This is just a consequence of the absolute values here. Now I'll talk about absolute values in a minute if you're not too sure. What you can do is just square both sides, right? So if I square the left-hand side and the right-hand side, because this is positive, I can keep the same inequality. So I've squared the left-hand side, I've squared the right-hand side, and I get something like this. Okay. Yeah, Horace, we can do a graph. We can definitely do a graph. So now, because we can move this to the other side, thus move that up there. Okay, so let's expand this and see if we can simplify. So x squared minus 2x plus 1. So we're still trying to simplify this. So we're going to get some cancellation here. So that's going to cancel, that's going to cancel. This is going to be, bring that to the other side. We're going to get, so divide by 4, which is positive. All right. So x is positive, and I think that's what was posted in the chat right at the start. Okay, so what's another way of writing this? Well, x is like that. All right, so that's the inequality way of writing it. X is just greater than 0. This is the sort of set way. X is in this interval here. And if you wanted to draw it, no worries. You can draw it on the number line. There it is. Okay. All right. So there's a good conversation going on in the chat about the absolute value. So let's just refresh our memory on absolute value. What's the you guys put it in the chat. What's the absolute value of 9? Who can tell me? Right. And what about the absolute value of -2? What's the absolute value of -2? Yeah. You guys ruled. Desmos crew. Okay. So when you take the absolute value of something, it doesn't matter what's in the inside. It's always going to be positive unless it's 0. You can tell me what is the absolute value of 0? Horace. Yeah, it's 0. Okay, so thank you, everyone. So no matter what you put inside the absolute value, you can't get a negative thing. Okay. Now, one thing we didn't check was this thing. Okay, I didn't check that. I should have checked that. That's obviously not a problem because -1 isn't in this set. So, phew, we should have checked it. I didn't, but we're just happy. Oh yeah, thank you, Oliver. Okay, so I should have checked that, but I didn't. Okay. All right. Okay, so we have about another 10 minutes. So that's enough for the questions. Why don't we actually, in the chat, if you want to ask some questions about this course, or you're a bit unsure of what to do where, just hit me up with the chat. You know, I've already said that. Let me just share that. I've already said that the way to do well in this course is to maximize your marks in the weekly quizzes, the 2 lab tests, and the writing assignment. Okay? And then the final exam basically separates the high distinction, credit, pass, and the other stuff. Okay? So let me have a look here, and we can take your questions from the chat. All right, let me just go back here and I'll show you my big fat head, and I'll kill that. Okay, I'm back. All right. So what have we got in the chat, people? All right, let's have a look. Let's have a look. All right, Cheng Tao, what do we do for the lab test? Okay, the lab test is a test on Maple TA. I think it's about 40 minutes, and you'll be asked to solve some questions during a specific time period. Okay, so the test will open and you'll be able to do the test, then the test will close. Okay. Why is there a lab test for math? Lab test just means you're using, like traditionally, people used to go to a computer lab to do these tests, but not now. So lab is not really a laboratory. Okay, it just means you do the test on your computer. Okay. Yarasimbo, hello. What is the work tied to the tutorials? Do we complete the course outline work or the Maple stuff? Okay, good question. So I think your question there is about the course pack, and you have like 200 questions in the course pack, right? But you also have questions in your weekly assignments. The weekly assignments are the ones that count for your final grade. And if you want to get good at those, the idea is to practice some of the course pack questions. They can help you with that and the final exam. Okay, so students pretty quickly work out that where are the marks? Give me the marks. Come on, give me the marks. Give me the marks. They realize, well, the marks are on Maple TA for the weekly quiz, so you should do those. The marks are for lab tests, you should do those. And the marks are for the writing assignment, you should do that. Okay, so there's no assessment tied to the tutorials directly. Rabia, is there a weekly homework? Yeah, the weekly homework is the Maple TA weekly quiz online. So you should do that and submit that, okay? And there are some recommended problems from the course pack. Saxon, is there much, so you can access it, Rabia, via Moodle. There's the Maple TA link in Moodle, which you need to go to. Saxon, is there much extension to related content? There's some things that you probably haven't seen before. You've seen some things with extension to maths in New South Wales, but there'll be some things that will be totally new to you, like a lot of the calculus. Okay. Van Andrew, hello. Hey Chris, can we just drop into any tutorial? Yes, you can go to any tutorial you like. If you prefer to go with one tutor or one style, just go there. Just have fun. Just enjoy it. Peter, what is the style of the weekly quizzes and how do we get into it? You get into it through Moodle, and the style is mostly multiple choice questions, and some you just need to enter some small Maple commands. So let me just show you. I'll see if I can bring it up. Where are we? I'll just look in the background and see if I can find it. Let me just. Oh. Uh-oh, I've frozen. Oh. I think I'm frozen, people. I might just go out and come back in. So just wait. Yeah, let me just kill something. I'll just come back in, okay? So I'm just going to kill Chrome. I'll come back in like 2 minutes. I can access Maple TA, John, but I'm not sure if it's open right now. I will check though, okay? You should be able to see the link in Moodle, and if it's not open, then not a problem. Avi, is Maple TA assumed knowledge? No, Maple TA, you need to learn it on your own. It's not too difficult though. It's pretty easy and you get a lot of hints. Kelsey, do I need to purchase a textbook? No, you don't need to purchase a textbook. If you want to, you can, but you don't need to. Okay, if you can't log into Maple, you can always try contacting the support team through the through Moodle. Yeah. I think there will be some assessment due next week. It's a good question. And Arnav, it's a good question. But just watch this space, okay? Rabea, I have got 5 tutorials per week. So there's plenty of time to come and see me. You can feel free to email me if you have a question. So I'm happy to take questions. But yeah, just either ask me in class or send me a message. That's no problem. Okay, Paolo. Do lab tests happen in one of our schedules math time? It should be in your timetable. Yeah, it should be in your timetable. So the times and whatnot will be posted on Moodle as well. So you'll get a lot of information about the lab tests. So don't worry, that's not until like week 4 or week 5 or something. Piri, oh, hang on. So Piri, you can go like whatever lecture stream you choose, just keep staying with that lecturer because you'll get the continuity of the ideas and the notes and stuff. So don't switch lecturers all the time because the lectures and the notes won't make sense. John, there's a list of books in the course pack. So one of them is Salas and Hill Calculus. I'm just putting that in the chat, sorry. Calculus. Next tune is this afternoon, Rabea, at 4 p.m. Sydney time. Yeah, Dharam, I think there might be a guide in the course pack. So just have a look because I think they use the textbook that I've just put in the chat and you can cross-reference it. Yeah, Arthur, yes, I think you need to change your settings either in Maple or your browser to have it in English rather than Chinese. So there's some setting that you have to change. Horace, no, the tutorials are different. Today's tutorial is mostly about me and like us together solving problems. This afternoon is totally different. Is totally different. So you should try a few different tutorials and see what you like. Okay. All right. It's 5 minutes to, and that's when we usually finish. So it's goodbye from me. Goodbye from my friends here. I'm joined by Spotty and Mario. Yeah, there'll be recordings, Rabea, in Moodle. You can access all of them. So just enjoy your first day, everybody. It's been great breaking the ice with you and getting to know you. So thank you. And hopefully see you next week or in another tutorial and just enjoy. And see you later from Spotty and Mario. They'll see you later too, okay? It's been fun. And I'm looking forward to getting to know you a bit better. All right? Thanks, everyone. I'll sign off.